Respected dignitaries, esteemed faculty members, and my dear all friends, I am Tejashri from Triple's department. So today I am going to talk about multi-objective optimization in the traveling salesman problem. It's basically a review. So let's get into it. So introduction to multi-objective optimization in traveling salesman problem. The traveling salesman problem involves finding the shortest possible route that visits each city exactly once and returns to the origin. So, traditional traveling salesman problem focuses on optimizing a single objective, typically the route length. Multi-objective optimization extends this by considering multiple conflicting criteria, simultaneously providing more comprehensive solutions. So before we get into this session, let me ask you a question. So, if a delivery person has to visit multiple cities and return to the same starting point, what is the best route? So, this is known as traveling salesman problem or TSP. Traditionally, the goal is very simple: minimize the total distance traveled. So, but in real life, things are not that simple. We may also want to minimize time, reduce cost, avoid traffic, minimize fuel consumption. This leads us to multi objective optimization. So, the traveling salesman problem is a classic problem in computer science and optimization. Given a set of cities, find the shortest possible route, visit each city exactly once, return to the starting point. This is not a hard problem, meaning it becomes very complex as the number of cities increases. What is multi-objective optimization? In real-world scenarios, we don't optimize just one objective. Instead, we deal with multiple conflicting objectives such as distance versus time, cost versus quality, and speed versus fuel efficiency. So instead of one best solution, we get set of optimal solutions. This concept is called Pareto optimality. A solution is Pareto optimal if you can't improve one objective without worsening the other. Multi-objective TSP or MOTSP. We apply multi-objectives to TSP, it becomes multi-objective traveling salesman problem. Examples: minimize distance and travel time, minimize cost and risk, minimize fuel consumption and emissions. So instead of one route, we get a set of best trade off routes. Methods to solve MOTSP, that is multi objective traveling salesman problem. Now let's look at some techniques used to solve MOTSP. First, weight sum method. Combine all objectives into one, assign weights to each objective. For example, total cost is equal to weight 1 into distance plus weight 2 into distance. Simple. But it is hard to choose correct weights. So, evolutionary algorithms. These are inspired by natural selection. Popular ones include genetic algorithms, NSGA2, non-dominated sorting genetic algorithm. How they work? Generate multiple solutions, select the best ones, combine and mutate them, and repeat until optimal solutions are found. It's very effective, produces multiple solutions. So Pareto based method. For focus on finding Pareto optimal solutions. Provide a set of trade-off solutions used in logistics, transportation, supply chain optimization, and colony optimization. Inspired by how ants find shortest path. Ants leave frenemy trails. Paths with stronger trails are preferred. Good for dynamic problems, works well for routing problems. Applications. So multi type of problem, salesman problem is used in many real world applications, logistics and delivery systems, airline route planning, and vehicle routing, supply chain management, network design. For example, a delivery company may want to reduce delivery time, save fuel, avoid traffic. You can use this. So, challenges. Some challenges are there where they include high computational complexity, difficulty in balancing objectives, large number of possible solutions. So, without any delay, let's get into the presentation. Overview of traveling salesman problem TSP. TSP is a classic combinatorial optimization problem with significant applications in logistics and manufacturing. Exact algorithms for TSP include branch and bound, dynamic programming, and integer linear programming, but they are limited to small instances. Appropriate and heuristic methods are often employed for larger problem instances to find near optimal solutions efficiently. Why multi-objective optimization in TSP? Real-world TSP applications often involve multiple criteria such as cost, time, and environmental impact. Multi-objective approaches provide a set of Pareto optimal solutions, allowing decision makers to choose based on their preferences. We have already discussed. In integrating multiple objectives enhances the practical relevance, robustness of solutions obtained. So the solutions are very efficient. Common objectives in multi-objective traveling salesman problem. Minimizing total travel distance or cost remains a primary objective in most traveling salesman problem variants. Reducing total travel time or ensuring timely deliveries are also crucial objectives. Additional goals include minimizing fuel consumption, balanced workload, and reducing carbon emissions. Multi-objective optimization techniques for traveling salesman problem. The evolutionary algorithms like NSGA2 and MOEA are popular for multi-objective traveling salesman problem due to their ability to explore complex solution spaces. Pareto-based methods focus on generating a diverse set of non-dominated solutions. Scalarization techniques convert simple objectives into a single objective, simplifying the problem but potentially losing some Pareto solutions. Challenges in multi-objective traveling salesman problem. The complexity of generating a complete Pareto front increases exponentially with the number of objectives. Balancing convergence and diversity of solutions remains a key challenge for optimization algorithms. Computational costs can be high, especially for large scale instances with multiple conflicting objectives. So applications, logistic companies optimize delivery routes considering cost, time, and reliability. Environmental agencies aim to reduce carbon footprint while maintaining the service quality. Urban planning and transportation systems utilize multi-objective traveling salesman problem for efficient infrastructure development. And we can also see Google Maps use this type of objective. So recent advances and trends, hybrid algorithms combining heuristics and meta-heuristics improve solution quality and computational efficiency. Machine learning techniques are increasingly integrated to guide search processes in multi-objective traveling salesman problem. There is growing interest in dynamic and real-time multi-objective traveling salesman problem models for adaptive routing. So conclusions and future direction, multi-objective optimization significantly enhances the practical ability of TSP solutions. Future research may focus on scalable algorithms for high-dimensional, multi-objective traveling salesman problems. Incorporating uncertainty and dynamic data remains a promising area for advancing multi-objective traveling salesman methodologies. So let's conclude with a short note. So, traveling salesman problem is a fundamental optimization problem. The real world problems require multiple objectives. MOTSP helps to find balanced and efficient solutions. Advanced algorithms like genetic algorithms and ACO are widely used. The goal is not just to find one best solution, but to find best trade-offs. So thank you for listening. I hope this gave you a clear understanding of multi-objective optimization in TSP. Thank you. Thank you so much. We are grateful for your interest and hope you enjoyed the presentation.